Hey viewers, myself Shiva Prasad. Welcome back to my channel. If you are new to my channel, please do subscribe and don't forget to tap the bell icon so that you won't miss any notifications from my end. In this video, we are going to understand about the basic functionalities of HashMap and why we need this data structure in problem solving. And I'm not going to deep dive into the HashMap internal working behavior because I believe there are plenty of good resources in the internet, in YouTube, or else any blog articles, and I highly recommend you to please go through by them. But if you feel you need a lecture from my end, please comment on this lecture so that I can try to make a video on HashMap internal working behavior. Without further delay, let's get into today's. In this video, let's try to understand the significance of HashMap data structure and why we need this one. Let's take a case. So how you choose a data structure to solve a particular problem. Okay. Below are the common operations that we can perform on any data structure, right? So if you have linked list, hash map, arrays, anything. So the basic most frequent common operations are like insertion, deletion, and searching, right? We need to choose the right data structure based on most frequent operations to be performed. Am I wrong? Let's take into the example. Assume you are most frequent operation is to insert an element at beginning. Okay, this is what your most frequent operation. Then which data structure do you think of here? You go with hash map, you go with arrays, you go with linked list. Which one you think of? Just do comment on this video. Without further delay, let's try to understand what is the hash map. Okay, so I'm morely focused on the Java language. So if you feel the syntax are scary, please do let me know. I can able to help you in understanding in much better way in written version also. Let's try to understand the hash map. See, generally hash map is a data structure, okay, which stores data in the form of key value pair. If you look at the linked list, so where data will be stored in the form of node, right? So if you take the single linked list, so it is going to have two fields. One is data, one is the pointer, which points to the address of next node, right? So likewise, different data structure stores data in different forms, okay? HashMap stores data in the form of key value pair, but HashMap in Java implements a map interface. What this map interface will do? Generally, it maps keys to value. Okay, every key bound with a value. And here key is an object which you use to retrieve the value. Okay, so if you have key value pair like Shiva followed by name followed by Shiva. So if you give the name, then it will retrieve the Shiva. Okay, so like that the pair will be formed here. So K is a type of key and V is a type of value. But this map interface around like it revolve around two basic operations like get and put. And our hash map also revolves around this get and put also. Let's go a bit deeper. This map, like the map interfaces, okay, these are the classes which implements the map interfaces. Like we have abstract map, enum map, hash map, tree map, weak hash map, linked hash map, identity hash map. And you can see their purposes also here in the description. So you can refer to the Java complete reference book authored by Herbert Shield, and these are the informations provided in that book. And I highly recommend you to go through that book if you are a Java lover. But let's try to understand. Okay, HashMap we understood. Okay, it stores data in the form of key value pair. It implements the map interface. These are fine. But like, why do we need HashMap, right? So there should be some purpose behind the requirement of the HashMap in a problem solving. So the one of the major reason is HashMap provides a constant time complexity in an average case for basic operations such as insertion, deletions, search, assuming there is no hash collision. Okay, let's take an example. So you are having some five records, okay, and five records are stored in five different buckets. So absolutely your time complexity of get operation is going to be big of n. But what if there are 100 nodes in one bucket? Okay, so from Java 1.8, so the nodes in each bucket, once it crosses certain threshold, that will be converted to balanced binary search tree. That means it is going to take log of n time complexity. Okay, but if there are no hash collision, that means every bucket holds only one node. In that case, like your time complexity is going to be big of one. So for put also, it is going to take big of one time complexity in an average. But what is mean by this hash collision? See, hash collision is a kind of situation where two or more distinct records, okay, returns the same hash value that points to the same bucket position in your hash table. Okay. And if you are unable to understand these terminologies, I highly recommend you to look at the HashMap internal working behavior. Then you can able to correlate this. Okay. But in order to handle these hash collisions, okay, there are different strategies we have, like separate chaining with linked list. Like before Java 1.8, so whatever nodes are inserted in one bucket, so they forms like a chain. So the first node occupies the bucket, but if there is another node which needs to be inserted in the same bucket, then it forms a chain. Okay, so like that maintained. But from Java 1.8, so instead of linked list, so after certain threshold, that will be converted to balanced binary search tree because it is going to reduce your time complexity from big of n to big of log n. Okay. And let's try to take an example. If we take any data structure like linked list, ORLs, arrays, anything, sorted array or unsorted array. So they will take a big of n time complexity for basic operations. Some constraints applied here. So what are those? Let's take you have an unsorted array, okay, and you need to find some element whether it is exist or else not. So how much time complexity is going to take? In worst case, it is going to take you the big of n, where you need to traverse till the last node, last element in the array, right? But if the same requirement, like you need to find an element in an array, but here the array is sorted, then what you are going to do? You can apply the binary search algorithm here. Your time complexity is going to be log of n, big of log n, okay? And likewise, if you take the linked list, so you need to find a particular node in the linked list. So assume that node is last node in the list. Okay, it is going to take you the big of n because linked list does not provide you the access to element based on the index, right? So these are the few things behind the hash map. So we are going to solve so many problems here. So many in the sense around 30 to 40 problems on these data structures. And those are I curated by with the help of resources like Lead Code, Interview with Geeks for Geeks from their most curated and most frequently asked interview questions SD sheets. Okay. With this, I'm going to conclude this video. And if you have any doubts in understanding the hash map, please do let me know. And I again reminding you, please try to learn about how hash map internally works. I mean, how get and put method works internally. But if you want that lecture to be recorded by me, please do let me know in the comment section. I will be very happy to record that also. Thanks a lot. Bye bye.